show that for the normal distribution, mean and mode coincide. Show that. Okay. Now suppose mu is the mean of the normal distribution. And further suppose that m is the median of the normal distribution. Now in case if m is the median, it means that it is dividing the distribution into two parts equally. So you could say this, that integral of minus infinity to m fx dx. Okay, this should be equal to half. Fx is the probability density function of x when x is a normally distributed variate. What does this imply? What is fx? For a normal distribution, it would be 1 upon sigma root 2 pi into e to the power minus half x minus mu upon standard deviation whole square. It is defined for minus infinity to infinity. Okay, so minus infinity to m, this integral fx dx should be equal to half. So this is a constant, so it will come out of the integral sign. So it is 1 upon sigma root 2 pi integral minus infinity to m e to the power minus x minus mu square upon 2 sigma square dx. This should be equal to half. Okay, now what does this imply? This implies that 1 upon sigma root 2 pi minus infinity to mu. So this implies this, that you've broken this minus infinity to m into two integrals. So supposedly if mu lies below m, so you can decompose this integral into these two integrals from minus infinity to mu and then mu to m. Okay, and well, you have to remember this, that for a standard normal variate, minus infinity to mu should be equal to half. Now in case if you convert this into a standard normal variate, where standard normal variate is given by x minus mu upon standard deviation, then for a standard normal variate, minus infinity to mu should be equal to half. So you can actually say for a standard normal variate 1 upon sigma root 2 pi minus infinity to mu minus this is converted as now for a standard normal variate, it will you can actually write this as 0 to infinity z square by 2 dz would be equal to 1 by 2. Is that okay? So what have you done is that you've said this, that the first one, okay, so the first one so when x is equal to minus infinity, okay, then z would be equal to infinity, and when x is equal to mu, then z would be equal to 0. So if you write whether infinity to minus infinity to 0 or you write 0 to infinity, that would mean same, and that is the reason it has been written like this. Okay, so See, because when x is equal to minus infinity, z is equal to minus infinity. When x is equal to mu, z is equal to 0. So if you write minus infinity to 0, it is same as 0 to infinity. So it has been written like this. So the first one, the first integral is basically half. So how do you write this? Half. The first one is half plus this integral again, 1 upon this integral. Okay, this one here. So this was basically for both here. Yeah, I'm sorry there. So it is 1 upon sigma root 2 pi integral mu to m minus x minus mu square upon 2 sigma square dx should be equal to half. So what does this mean? Well, this would mean that 1 upon sigma root 2 pi, this integral should be equal to 0. Okay, and this is equal to 0. It means that these limits are equal. So this would mean that mu is equal to m, and this is what we wanted to prove. That is, for a normal variate, mean is equal to the median.